Welcome to another version of Field Phone Ops. Today's episode we're going to talk about radio wireline interfacing, and that's basically radio remoting using tactical phones and switchboards. So sit back and enjoy and follow along as we discuss this. I've done some previous videos where we talked about remoting Vox radios using TA312 as the interface, an actual 2-wired 4-wire hybrid converter box, and then actually just using a transformer, a TY146 transformer. Basically, I went back and relooked at some of these approaches and did some more research on it because I've had some people ask me some questions. So I sat down and looked at some stuff and made some, I don't know if you had discoveries or learned some things I'm going to forward on to you that'll hopefully make it a little bit easier if you want to try to do this. And you have success at doing this. So go ahead and sit back and we'll start going through the new stuff that I learned and I'm presenting. First, we're going to talk about the audio connectors. There basically are two different sizes you're going to use. You're going to use a 2.5 millimeter and a 3.5 millimeter. Now these will come in basically three different versions. This is very important because if you don't get the right version, stuff's not going to work. There's a tip, ring, and sleeve plug, the top plug, which basically has a tip and a sleeve. Basically, that's a 2-wire connection. If you were to unscrew the black cover on it, you'd see there's contacts for soldering 2 points. The next one in the middle is a tip, ring, and sleeve plug. Basically, this is for 3 connections. You can see if you were to remove it, like I said, there would be a tip, ring, and sleeve contact. Another thing I want to say is if you have connectors like this and you're not sure when you're getting ready to solder which one's is which, get a multimeter out and go ahead and touch the tip and do a continuity check to the right contact on the inside. I always do this just to make sure I don't inadvertently solder something in the wrong place. And the last one you'll see is actually a tip, ring, sleeve. And these are becoming more prevalent. You'll see these with a lot of cell phone applications in that. But this is just another one. This is a difficult connector to solder because it's a small connector anyway. And with the 4 contact connecting points, you have to take your time. But I'm showing you this because this is a big deal, as I'm going to explain on the next slide. Okay, now I went out and I researched the different kind of styles of connectors for these radios, and basically this is it. There's basically just 4 or 5 different kinds of types. Everybody's sort of standardized, and these are molded connectors. You can see the molded connector on the left, and the deal with these is different companies, or vendors I should say, will make different distances between the pins. So some of them are 10 millimeters, some of them are 12, some of them are 8, which makes a big difference on these molded plugs. That's why I choose, when I build my systems, to actually use the individual separate plugs. And you can see I went through here and I labeled them all out: the ground, the mic, and the speaker. Some of the interesting ones are, if you look at the Yaesu 1 pin, there's a not used on there, and that's a pin that's not used for anything. Likewise, if you get down to the Kenwood Baofeng one, there's actually on each of the connectors, there's actually a data contact point and a 5-volt contact point. Now you don't want to use these because that puts the radio into programming mode. And also, if for some reason you get these swapped around, actually, a person contacted me about stuff not working right, and it turned out he was trying to use my Midland pinout connectors that I did for my Midland radios on his Baofeng radio. And if you notice, the speaker on the Midland uses the big plug, and if you do that on the Baofeng, that's the actual mic one. So it's a big deal. And also to make sure that you use the right pin. So if it calls for a 3-contact pin or plug, you use a 3-contact plug. Otherwise, you risk shorting together some of those contacts in there. Now, it probably won't damage the radio, but I'm sure it probably is not going to work correctly. So this gives you an idea of basically, if you were to use the individual plugs, like I recommend doing, these are where you would do your connections at, or basically what the connection points are in each plug. Okay, next we're going to go into actual schematics of several different systems. Okay, the first method I want to talk about is the TY146 transformer method, and this is one of them that I did, and it works well. I'd recommend using this or one of the other transformer method instead of having to waste TA312 phone to use as the interface to the radio, especially since there aren't a whole lot of them around, and if you have a couple, you want to race one of them just dedicated to a radio circuit. So this is what I would do. Basically, I took the TY146 and I made some changes to it. The first thing I did was I did some research and tried several different nations, I should say countries' field phones, and discovered that all the output on the audio side are the same. So I decided, it'd be easier if we could find a way to put a adjustable potentiometer in there instead of a fixed resistor. So that's what we have in there. I tried using a 100K and a 200K pot or screw pot in there. It's a little knob you adjust. And what you do is you go ahead and you adjust this to get your audio set to where you want it. So basically you would go ahead and set your Vox level on your radio, probably to a mid-range, and then go ahead and do some tests and adjust this. I also added some capacitors in there, C1 and C2, which are 100 microfarad capacitors. And the point of this is to keep any direct current voltage that comes out of those radio connectors that sometimes gets onto connectors or inadvertently and keeps that direct current out of the transformer, which will cause noises in that. So that's why those are in there. I also took and mounted this on a small perf circuit board into a little package that you could easily mount inside a waterproof box with binding posts and a plug, and I think that'd be a much easier way to deploy it. I think by using the potentiometer, it's the way to go. It gives you the ability to hook a different kind of field phone up and adjust the level for it, and you're not stuck using fixed resistors. I also would recommend not using or wasting one of your field phones on connecting it to the radio. So we'll go ahead, and I also found another transformer that will work, and we're going to talk about that one next. In my research, I found another transformer that will work, and it's a TTPC-14. It's roughly the same size as the TY146. It's a little bit wider, just slightly bigger. It's also wires a little bit differently. You have to look at it closely. If you notice on the picture that I'm showing on there, or the diagram, there's no jumper on it. So if you go to the transformer schematic up above, there's no jumper on it like there is on the TY146. But you have to look really closely at the terminals on the transformer itself, and you'll notice that in the picture that's on there, I'm holding it in my hand, the top 4 terminals, there's 2 on each side. Well, the only ones that are used for wiring are the 2. These have solder on them, is how it's easier to tell. But if you look at them real close, you'll notice that the 2 outside terminals don't have any kind of wire connections to the transformer winding. So that's another key to using one of these instead. Once again, I would mount this on a perf board. It's got your potentiometer on there, so you can vary your resistance. Your capacitors on there to help keep any kind of noise or direct current out of there that would cause noise. And I tried it out. It worked well. I'm going to put one together and do some testing on it. Like I said, I would not waste time or waste assets using TA312s to make Vox radios. I'd go ahead and use a transformer. They're cheaper, smaller. There's no batteries required. Easier all around. The next one I'm going to do is I'm actually going to go out. We'll go out to the patio. I'll get my stuff out, and we'll actually hook up one of them that I made, and we'll do some checks with it. Okay, here we have the new and improved system set up here in the patio. We're going to do some checking. Here's the actual control board right here. It's got our TY146 transformer on it. I've got a capacitor on the transmit and receive side to help clean the noise up. And here's the actual potentiometer. This, just by adjusting that, you can cut back the squeal and get your resistance set right so your impedance is good, which caused a lot of your squeal. So we'll go ahead and we'll do our first radio check using the 312. Test. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Test out. Test. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Test out. Seems to be pretty good. Now I'll go ahead and I'll mess with the knob, and you can see what the adjustment will do. So if we go this way with it, test 1, 2, 3, 3, 2, 1, nothing. So we'll go ahead and start bringing it back to it was about center place before. Test 1, 2, 3, 4, 5. So there you go. That gives you the ability to adjust it. The radio itself is set for a box input level on the radio as of 3. And basically what this potentiometer is doing is you're adjusting the level of the audio that's coming out of the phone through the wire, through the transformer, and going into the radio microphone. So that's basically what it allows you to do is tweak that so that it doesn't squeal. I have my binding posts on here, and hopefully I'm going to put this into a box sometime and try from there. Okay, now we're going to go even crazier. We're going to get rid of our TA312. And we're going to install our TA57 made by the Soviet Union. I want to do this because the TA57 has got a lot higher output levels on it than the 312 does, because it's got, the Russians build them, they put in some actual amplifiers on the microphone output side, so it's a little bit louder, or a little bit louder. We'll go ahead and pick it up here, we'll see what happens. Test, 1, 2, 3, 4, 5. 5, 4, 3, 2, 1, test that. That's a little bit on the high side, so what we'll do is we'll come in here and we'll adjust our pod a little bit. Test. 1, 2, 3, 4, 5, 6, 7, 8, 9. A little bit high. We'll go ahead and go a little bit further. Test. 1, 2, 3, 3, 2, 1. Test. Test. 1, 2, 3, 3, 2, 1. That sounds a lot better right there, but that basically gives you an idea how you'll set the level. Different phones have different levels, different people's voices have different levels. So that's basically how it works. I thought about putting together an actual bill of materials and going out there and building these for people at cost, if people would want me to do that. That way this one is actually built, put the connectors on it right here to use on a Midland radio. If you had a Baofeng or Midland, Baofeng, or a Kenwood, I'm sorry, the connectors are going to be a little bit different, especially the pinouts, what lead goes on which one. So I would be willing to go ahead, if you'd send me the kind of radio you want, I could custom build the box. But I'm going to have to get together a bill of materials first, get a cost idea, and then if anybody wants one, contact me by the email at the end of this video, and we can go ahead and talk about getting one done. I don't think they'll be that expensive. What I was thinking about doing was basically just installing this into a ruggedized box that would have the binding posts on it, have a little bit better cables on it. It would be, you know, a little bit more rugged than this is right here. And if anyone's interested, go ahead and contact me. But this is the new and improved box radio remoting using a TY146 transformer. I have a TTPC14, which is the other transformer I discovered you can use for it. I don't have any more circuit boards, so I can't build it anymore. So when I get one of those put together, we'll probably come back, change this video, and change it. So, and that's it. Thanks for watching.